With our high drive system and a larger mover and a larger magnet, we're able to move heavier loads just as fast as we're able to move light loads with smaller magnets. We can also lift more, so it allows us to do more work on bigger objects. So basically applications that were in the past not doable with a small mover and a small magnet are now possible, and other applications which were perhaps heavy can now move even quicker with higher accelerations and higher speeds. And here now we'll have our setup with 4 kilograms loaded on each of the movers, and we can run them with a 2G acceleration, and we can lift in the curve. And let's see this now running. So here we have our GFX XTS system combined with a HEPCO high drive and a high drive plus system. So for the high drive, we've taken a larger mover. This mover is 100 millimeters wide and it's got a bigger magnet on it. We've put a 100 millimeter magnet on that, and it has a peak force of 210 newtons. This is intended for larger loads and higher forces with larger loads. So this mover is now equipped with 4 kilograms combined with the 1 kilogram mover, and 200 newtons. We're able to achieve 4G acceleration and our top speed of 4 meters per second. When we need to go heavier or we need to put a cantilever on the mover, we go to the high drive plus. And with the high drive plus, we've now got another mover on the bottom that's supporting the extra load from the top. So we can put a much heavier load on the mover and we can cantilever it further out. A drawback to the cantilever is that when we enter the curve, the mover has to turn the entire mass. And for such a mover or such a configuration, then we will typically slow down in the curve. To avoid that and to go even heavier, we'll go to a high drive plus system with 2 movers coupled together mechanically. This way, when the mover enters the curve, the twisting force on the mover is picked up by the second mover behind it, and when we come out of the curve, it's transferred the other way. This allows us to put a massive amount of weight onto our movers. This mover configuration can carry a maximum of 90 kilograms. Here we have it set up with 20 kilograms. So we've got 20 kilograms on this mover pair, 5 kilograms on this mover, 4 kilograms on that mover, and all of these configurations can reach the maximum 4G acceleration and 4 meters per second motion. So let's now see it in action.
Well, thank you, Rob. That's a fascinating look at high drive, you know, a solution that really sort of allows us to move into new areas and new applications. Tim, quite impressive, the types of loads that Rob's just been showing us there. And, you know, using a standard mover as a reference point, clearly high drive is bigger. Can you tell us a little bit more about the actual mover itself?
Well, you're absolutely right. The high drive is bigger. It uses a larger magnet array, which starts off with more drive force, but also greater payload. We've gone from the very small bearings on the Agile up to much larger bearings on the high drive. Much higher capacity, much higher radial capacity and axial capacity. The mounting faces are much more substantial. And It's just bigger and heavier and well suited to these high loads.
Thanks, Tim. And I guess, you know, one of the big questions that our viewers are going to be asking is, you know, if you take a sort of a standard mover and compare it to high drive, you know, if I took a lump, some sort of product, and stuck it on top of the mover, you know, what sort of capacity gains are we seeing with high drive?
We're looking at 100% gain. We're looking at twice the capacity.
Okay, well that's pretty impressive indeed. And I guess, as with anything, there's going to be some sort of trade-off. If it's heavier, I guess you can't move it as quick.
That's exactly it. We have this larger mover is 40% heavier than a standard mover. The bearings are much larger. The overall mass obviously precludes high accelerations. We've got the rotating mass and the overall mass of the unit. But we're talking about big payloads, so we're not expecting to see agile type accelerations on 20, 30 kilo payloads.
Okay, no, that's interesting. And you know, when we talk about those sorts of payloads, it's really moving XTS and GFX into new areas, new industries. I mean, I guess, you know, it makes us viable for sort of automotive type applications where you've got sort of larger assemblies than typically we'd be used to.
Absolutely. We're also looking at large crates of product. So with the end of line processing, where we're moving perhaps 20 or 30 kilo crate of liquids or solids into packaging areas.
Yeah,
so we've gone from processing all the way through to final packaging.
So you might have a standard XTS GFX that's doing the individual bottles or packs or something, and then you could have a high drive system which is moving the full boxes of multiple products.
Absolutely, and it allows that integration from one process to another with the same control system.
Brilliant. Thanks, Tim. Very interesting.
Alex.